Good morning, students. Today I am going to teach circles topic. Already you have learned the circles topic in ninth class. What is the circle and what is meant by chord and diameter, radius. So these are all the terms we have studied it before. Now, once again I repeat what is circle means. It is a set of infinity points which are equidistant from a fixed point is called a circle. That fixed point is nothing but center of the circle. See here, this is set of infinity points over here, and which are equidistant from the fixed point. Means this distance and this distance and this distance will be same. So this fixed point is called center of the circle. Okay, and the fixed distance is called what it is radius of the circle. Okay, and a chord means what is a chord? A line segment which is which has two endpoints on the point circumference of circle is called chord of the circle. Suppose if I'm taking a circle over here, okay, if I'm taking circle, this is a center, okay. A chord which is passing through the center of the circle is called diameter. Diameter, okay, and means the longest chord in the circle is called diameter. Okay, diameter also can be written as twice of its radius. Why? Because this is radius and this is radius. Okay. Now, these are all the things you know very well. And what is secant of the circle? A line which is passing through 2 points on the circle. Any 2 points on the circle is called secant of the circle. This is secant of the circle. Okay. Now, see here. Now, let us examine this diagram. So the line and circle different positions over here. If line is intersecting at two different points, if line is not intersecting, and if line is touching at one point only. Here, not intersecting, not intersecting, not intersecting the circle and intersecting at two different points. Intersecting at two different points. At 2 points and touches the circle. In this case, means intersecting it means touches the circle at one point. Circle at one point. Okay, now at one point. Okay, so these are the three cases will be over here. Okay, so now say here, if a line touches the circle at one point is called tangent to the circle. Means this is called tangent to the circle. If a line touches the circle at one point is called tangent to the circle, and this point is called point of contact, A. This point is called point of contact. Okay. Now see here. Now when you observe this diagram, means it at one point we can draw only one tangent only. We cannot draw the number of tangents through one point. See, if you see this diagram, we have drawn this point. If I am taking over here, for example, so this point, if you see, consider this one, we are drawing only one tangent. That tangent will be, this is the tangent. Okay, now only one tangent we can consider over here. If this is this, if you consider this AB is, this is intersecting at two different points. This is not a tangent, and this is not a tangent, and also this is also not a tangent. Okay, now, and this will be the tangent. Okay, and this is not a tangent. Why? Because it is intersecting at two different points. This is not a tangent. This is not a tangent. Means what I mean to say to you, the thing, through one point we can draw only one tangent. Okay, so that is highly impossible. We can draw the unlimited tangent to one point. Okay, now, so only one tangent we can draw through one point only. So that point is called point of contact. Is it clear or not? Now see here. Now theorem is here. Okay, so now if you consider this theorem, what is that? See, the tangent at any point of a circle is perpendicular to the radius of the radius through the point of contact. Means, so this is the tangent. Xy is tangent. Xy is tangent. Okay, now xy is tangent, and P is the, this one will be the point of contact. Point of contact. Okay, now so we have drawn only one tangent through this one point. Okay, the statement goes to what it is over here. It is the radius is always, this is the radius. This radius is always perpendicular to the tangent at the point of contact. Okay, now so the statement says that the radius is always perpendicular to the tangent. Means radius is perpendicular to the tangent. Okay, now through the point of contact. Okay, now through the point of contact, this one. Okay, see here. Now in this, I would like to say one more statement. This is a radius, and this is what it is called. OQ is what is hypotenuse. In right angle triangle, the longest side is hypotenuse. Means this, it can be written as OP is always less than OQ. Why? Because OP is the side only. Okay, now this is the, what it is, opposite side over here. This is adjacent side, opposite side, and this is hypotenuse. Always these two sides, if you consider this length of these three sides, means always hypotenuse is greater than the remaining two sides in right angle triangle. Okay, now why? Because this is right angle triangle only. So this is 90 degrees. This will be the hypotenuse. Okay, so OP is less than OQ. Okay, so once again I repeat, what is that? Always the radius is perpendicular to the tangent. See, the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, now see here, some more properties will see here. Number of tangents will be over here. Suppose if lines are intersecting, and the point of intersection will be the interior, inside of the triangle, circle. Inside of circle means there is no tangent will be over here. There is no tangent will form over here. Okay, this a point of contact will be inside the circle. If it is, if a line touches the circle, here out is touches the circle at one point. So this we can form here one tangent over here. That's what we have told you now, just now. A line touches the circle at one point is called tangent. Okay, we'll get one tangent over here. Okay, now it is on the circle. On the circle, it means the point is on the circle. Point is on the circle. Okay, now see here. If I'm taking outside the circle, exterior point, outside the circle, exterior. If the exterior means, okay, what is the meaning over here? See, if I'm drawing, we can draw two tangents from one external point. Two tangents we can draw. Anywhere you can take. Here I am taking outside this point. P is outside the circle. Okay, now we can draw two tangents over here. Okay, if I am taking, suppose this circle. If I am taking, suppose here some Q I am taking. Here also we can draw two tangents. Okay, now through an external point we can draw two tangents. Okay, this is one tangent, this is one tangent. This is A you take, this B you take. Means QA is one tangent, QB is also one tangent. Means what is final conclusion of this one? See, if the point of intersection will be P is inside the circle, means if P is inside the circle, there is no tangent. There is no tangents. Okay, now if P is outside on the circle, means we'll get only one tangent. One tangent. If P is outside the circle, exterior point, means we'll get the two tangents. Okay, now so this is one property. Now see here. Just now I told you that if I'm drawing two tangents through one external point, means it will get the two tangents over here. So, and I'm saying that these two are equal. See, the statement says that the lengths of the tangents drawn from an external point, to the circle are equal. Means if I'm drawing any two tangents from an external point, means these two are equal. Okay, now these two lengths will be equal. the lengths of the tangents. Okay, now PQ and PR will be equal. So what we have to prove over here? PQ is equals to PR. This we have to prove. Okay, now. So now you do one thing and join OQ, OR, OP. Okay, now. What is the construction? I am constructing join OQ and OR and OP. Okay, now see the proof. So these two are equal by this is the radius. Okay, now if you consider this triangle like a POQ and triangle POR. If these two triangles I am considering, if I show these two triangles are congruent, by property we can say that corresponding sides and angles are also equal. But first we'll prove whether these two triangles are congruent or not. Okay, now see here, I am taking this. This we know that always, just now I told you that always the radius is perpendicular to the tangent. Means what it is, OQ is perpendicular to OQP, right down here. OQP is equals to angle ORP. ORP. This is right angle triangle, 90 degrees. So, okay, this is 90 degrees right angle. Now, OP is the hypotenuse, common side. If it is common, and that is also it's a hypotenuse, right? Because this side which is opposite to the 90 degrees, that is called hypotenuse. Okay, now next, what it is over here? OQ is equals to, what it is? OQ is equals to OR. Why? Because this is a radius. So side. This is radius side. So by what we can say that by RHS property. So by RHS property, right angle hypotenuse side property, what we can say that these two triangles are congruent. So triangle POQ is congruent to triangle POR. Okay, now. So by CPCD, corresponding parts of congruent triangles, what we can say that corresponding sides are equal means PQ is equals to PR. That's what we have to show. Okay, now. Statement says that the lengths of the tangent drawn from action point to a circle are equal. Means we have shown these two are equal. Okay, students, I hope you have cleared all the concepts. Thank you.